Welcome to the MSDN show. In today's episode, we're going to continue with the theme of .NET architecture. Now, in the last episode, we talked about what the .NET architecture was in kind of a broad overview. In today's episode, we're going to tunnel in just a little bit on it. We're going to talk about the .NET framework and specifically what it is, how it affects your architectural designs in your applications, as well as for programmers, what it means to actually design applications using the programmable interfaces of .NET. But before we get to that, let's check in with the news and Erica.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. At the beginning of September, Microsoft, IBM, and Ariba jointly announced a new platform-independent open framework for describing services, discovering businesses, and integrating businesses' services using the Internet. This standard is called Universal Description, Discovery, and Integration, or UDDI for short. By taking advantage of existing standards, such as XML and DNS, and utilizing the cross-platform programming features proposed by SOAP, UDDI will be capable of providing an industry-wide registry of businesses in order to simplify the process of bringing businesses and consumers together. For more information about UDDI, as well as to find out how to register your products and services, visit www.uddi.org. In September, MSDN Online recently launched 2 new developer centers for Microsoft Office and Windows Embedded. The Office Developer Center targets the needs of application and solution developers who use Microsoft Office Developer. The Windows Embedded Developer Center provides developers with key information on how to scale embedded technologies to a broad range of intelligent devices. The developer centers offer an organized location for finding all technical information on a specific technology, such as articles, sample source code, documentation, and news groups. Visit the new Office Developer Center at msdn.microsoft.com/office and the new Windows Embedded Developer Center at msdn.microsoft.com/embedded. Microsoft recently made available the Beta 2 version of its Universal Plug-and-Play development kit. Universal Plug-and-Play is a distributed open networking architecture that leverages TCP/IP and the web to enable seamless proximity networking, in addition to control and data transfer among network devices in the home, office, and everywhere in between. The development kit includes tools, sample code, and documentation to assist you in developing and monitoring any UPnP devices that you develop. The current kit targets Windows 2000 and Windows CE-based systems. You can download the UPnP Beta 2 Development Kit from www.microsoft.com/hwdev/UPnP. On September 26th, at the Enterprise 2000 launch, Microsoft announced the general availability of its .NET Enterprise servers. The event marked the first step in the release of Microsoft's .NET platform. .NET Enterprise servers include BizTalk Server 2000, SQL Server 2000, Application Center 2000, Exchange Server 2000, Commerce Server 2000, Host Integration Server 2000, Internet Security and Acceleration Server 2000, and Windows 2000 Data Center Server. For more information about the .NET Enterprise servers, visit www.microsoft.com/servers/net.htm. And that's been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Today we're going to talk about the .NET framework. Now, if you remember the last episode, we focused on the .NET architecture. Now, the framework is something slightly different. And to help us understand exactly what the .NET framework is and how that applies to the overall .NET vision, we have with us Anders Hejlsberg. Anders, now you're a distinguished engineer at Microsoft working in the developer division.
Mm-hmm.
What exactly does that mean?
Well, it means that I do a lot of sort of overall architectural work, and I've in this particular product cycle worked on a new language called C#, and then also as an architect for the .NET framework.
Now, then C# and .NET are fairly tightly tied together, and that's where your expertise comes in.
They are. .NET framework is, the overall term that we use for the .NET runtime, the .NET class libraries, and the .NET languages. And C# falls in the latter category. But there's also, as I said, a runtime that underlies .NET, which in a sense you can think of as the next generation of COM. And then there's a set of class libraries that provide, common functionality to all of the programming languages that are hosted on .NET.
So then when you talk about the framework and referencing it to and calling it the runtime, to me that brings up visions of the C runtime or the VB runtime or something like that. A physical like DLL that's being moved around my application that is supporting some inline capabilities. Is the same thing going on here?
It's pretty much the same thing. You can think of it as, if you will, the next generation of VB run of the C RTL, if you will, except those were built for specific languages. VB run supports VB, MSVCRT supports, C++ and C. The .NET runtime and the .NET framework was built from the ground up to be multilingual, meaning that you can host any programming languages, any programming language you care to on the runtime. We're shipping 4 languages in this release, or in the upcoming release: Visual Basic, or VB.NET, Visual C++, C#, and JScript. But we're working with external partners, commercial as well as academic, to implement a whole host of other languages, ranging from APL to COBOL on the .NET framework.
And so they're accessing the runtime capabilities you're developing.
Well, they're employing the runtime capabilities, if you will, such as the garbage collector exceptions, class loading, security, and so forth, and they give you access to the class libraries in your applications, so you can leverage the existing set of base functionality that we give you, be that to build web services, to build client applications, to build ASP pages, whatever.
Now, in the previous episode, when we talked about developing applications for .NET, we talked an awful lot about different languages, being able to develop on COBOL and C# and Visual Basic, and have those different languages almost transparently call between themselves to share classes and so forth. Now, is it the runtime then, the framework component that's providing that infrastructure to call between the different apps?
Yes, well, it's the framework. It's actually, in a sense, both the runtime and the class libraries. If you look at sort of what's happened in the world of Windows programming over time, and let's say we go really back to the old days where you were doing Petzold style programming, you would fire up your C compiler, pound include windows.h, you'd write your WinProcs, you'd have your WM blah blah blah, window message handlers and so forth, and you could definitely write apps that way, but it was neither easy nor particularly productive. And so what's happened over time is that we've sort of branched off from that common point and built different solutions for different scenarios, if you will. We have, for example, Visual Basic that employs principles such as delegation and composition, and RAD allows you to easily build client UI. We have MFC ATL that sort of have taken a different tack of building a more traditional class library where you use inheritance polymorphism. It's perhaps not as productive as VB, but it's more powerful. And then, most recently we've sort of seen the birth of a whole new way of programming with ASP, with code embedded in HTML pages. But one of the problems that we face because of this evolution, so to speak, is that your choice of programming model also becomes your choice of API and your choice of language. Like if you're writing an ASP page, well, you write either in VB script or JScript. And if you are, accustomed to writing MFC, C++ code, all of your skills don't transfer, nor do the APIs that you're accustomed to, like
because you're not going to have, create windows and message loops and
precisely.
Like
and so what we are doing with the .NET framework is, in a sense, we're reunifying all of these forces, if you will, such that we provide a consistent API that is available regardless of your programming model and your programming language. And that's really sort of one of the overarching goals for .NET.
Well, I know that one of the issues with like a VB programmer that was looking through the documentation and would find some standard Windows API function. They say, well, that's exactly what I'm going to get to. If that function wasn't exposed to the VB environment originally, you couldn't call it.
Right.
And so
Right.
eventually they had to add some capabilities so you could actually do call outs and redefine
Right.
those functions so you can call them properly.
Right. And I think that, but one thing you also see there, this is, so what you're talking about here is using like the declare statement in VB and importing, entry points from DLLs. But that's really, it's not really a particularly integrated way of programming. You got to declare all these function headers, and it doesn't really feel natural in VB. One of the things that's very different about this upcoming release of VB is that it is a first-class player in this platform. There's nothing special that you have to do to use .NET in VB, to import APIs. Everything is there as a first-class thing. VB also now, in this upcoming release, will support inheritance, polymorphism, allow you to inherit classes from existing base classes. And indeed, you can write classes in C++, inherit from them in C#, and use them in VB, or any combination of those languages. It's truly multilingual, and everybody's a first-class player. So there are no more penalty boxes, if you will.
And it's the framework then that is allowing VB.NET to do this?
It's the runtime that allows VB.NET to do it, and it's the framework that we will all share, if you will, or the class libraries that we will all share. But yes, the framework as an overall, yes.
So then how does the framework apply to this larger vision of integrated web services and so forth? Because a lot of time when we talk about .NET, it's always this big, big cloudy sort of discussion about web services and sharing apps across stuff. Where does the framework exactly fit into that model?
Okay. Well, one of the things that I think characterizes the framework is that it was designed from the ground up to incorporate web standards and practices. It is not, something that we've come in and sprinkled on, as an afterthought. If you look at other ways of building applications out there, most application development tools today have roots in the client-server space, and really, are sort of optimized for building two-tier applications, traditional client-server applications, or perhaps are optimized for using an object request broker or an ORB like Corba or DCOM, to do their distributed application infrastructure. From the very get-go with .NET, we realized that that sort of an architecture is not going to scale to the global scale of the internet. One of the problems you face with say, Corba or DCOM is that those types of distributed applications tend to hold state on the server. They first of all tend to be strongly connected. You create a connection, you get a proxy object back, you're sort of holding, on the client you're keeping alive some state on a server. And the problem with that is it doesn't really scale to web farms. First of all, the quality of the connectivity over the internet is just not good enough to do that. And second, you can't just roll in more machines and scale out, because once a client has hooked up to one server and is holding state on that server, he better stay on that server. So what we've tried to focus on is a more loosely connected, stateless programming model. And instead of using, proprietary protocols like IIOP or Corba or DCOM, we're using HTTP as the carrying layer, and we're using SOAP XML as the protocol over HTTP. So this gives you a number of advantages. First of all, it just works with existing firewalls. Second, it furthers, this disconnected programming model, because, you can shoot off an HTTP request that contains a SOAP body, invoke a web service somewhere, it returns its result, and then there is no further record of that connection. The next time you come in, you could come in on another machine, so you can scale it out, you can use sort of the web practices that we use for scaling of your applications, yet you can get a view of the world that looks like objects and classes and methods and so forth.
Now, with all this talk about, applications and SOAP and XML and HTTP requests and stuff like that, if I was designing an application that wasn't going across the internet, if it was just staying on my local machine, does that mean I can't use .NET for that?
No, absolutely not. What I'm saying is just that, if you are building distributed applications, we give you this great infrastructure in place. And it actually ties in nicely, even with apps that are not distributed. That doesn't necessarily mean that you have no need for XML. and our XML parser is not, specifically tied to doing SOAP. It's a general XML parser. And also, of course, the framework includes support for writing traditional client applications, for writing web server backends, or for writing just computational applications, that do file I/O, for example.
So what if I had a legacy application, existing application based, some big, database querying service sort of thing that I was putting out on my Windows system? Maybe it was running across the internal network, using very tight coupled network connections across there. How would I take advantage of the .NET framework and environment in this existing application?
Well, I think what you would do is you would in a sense stay with the same architecture that you have. You would evolve in a sense. First of all, we don't really believe in throwing away your existing code, and rather we focused heavily on giving you ways to interop and to evolve your existing code.
So I wouldn't have to rewrite it in C#.
You would not have to rewrite in C#. And say you're writing in C++, for example, well, you would use manage C++, and we have, in fact...
so I've got to rewrite it into manage C++?
No, you do not. All you have to do is throw a switch on the compiler, and it's the it just works switch.
I've heard that before.
Yes.
I mean, really, if I've got code, I don't have to go in, but you called your pointers wrong, or you did this wrong. I can take existing code and just throw a switch, and for the most part, it should just compile?
Yes. That's precisely what the design goal of that feature is. You throw this switch on the compiler. Instead of compiling to traditional unmanaged code, we now compile your application to managed code. Now, of course, that doesn't mean that you automatically get garbage collection of your objects, because C++ is fundamentally not a garbage collected language. But it gives you a lot of the other features of the .NET framework, such as deployment and security. Plus, it gives you great interoperability with the .NET framework, so you can write these hybrid applications, that do a bunch of traditional stuff using traditional C++ classes, yet also use managed or garbage collected classes from the .NET framework.
Now, in the last episode, Mark Anders showed us some sample code where he said, here's a standard C++ way of registering event in the event log and putting a message into it, and it was standard MSDN code. He got online, it was like 3 dozen lines of code. Looked pretty ugly, really. And then he showed the C#.NET version of that, which is like 4 lines of code. So let's say I've got this legacy application. I decide that I need to take and do something in event log because I know it's important, but this code is ugly. I want to use this C# code. What would I have to do to take and use those 4 lines of code? Could I include them in my managed C++ code, or would I want to call something outside written as a C# thing, or does it matter?
Well, you could do either. First of all, managed C++ and C# are, in a sense, very similar when it comes to using managed objects. It's the same syntax, object.method name, paren, arguments, for example. It's the same syntax to instantiate objects. You use the new operator and so forth. The thing that managed C++ gives you is the ability, in a sense, to write both code that targets traditional C++ classes and code that targets the new garbage collected class model in the .NET framework within the same method. You can mix and match even within the same expression, if you will. And of course, that code could be using a class that was written in C#, because once you're using the .NET framework, any language can consume any other language's API.
The framework's just making that transparent.
Yes, completely. Yes.
So then,
now one thing I actually wanted to add to this as well is that you mentioned how the traditional C++ way was umpteen lines of code, and in C# it was only 4 lines of code. I think that speaks to one other thing that we really focused very hard on, which is to dramatically simplify the development process, to enable the programmer to think about his algorithms instead of thinking about housekeeping. One of the things that's really plagued COM over time is this incredible amount of GUID, hresult, add ref release, co-create instance, put stuff in the registry, and so forth, and your code just explodes into this macro mumble jumble, that you can't read it. It's write-only code.
Which is why ATL came out, to make that a little bit easier for you.
Sure, but even ATL is still not for the uninitiated, I would say, and then we've really focused hard on making all of that housekeeping go away. There are no more GUIDs. There are no more H results. There's no add ref release. There's no co-create instance. It's all gone. And basically, it's replaced with intimate knowledge in the language of the underlying runtime.
So then, the runtime really is an extremely important part of the entire .NET story. It sounds like that's the thing that makes everything work properly.
It's sort of this ephemeral thing. You never really see it or physically, interact with it. It's just there, but it provides a whole host of very important services to apps that run under the .NET framework. One thing that comes to mind, of course, is garbage collection. Another is exception handling, code verification, class loading, threading model, et cetera, et cetera. All of these sort of black boxes, or this machinery is part of the .NET framework. It's shared across all applications, so everybody can leverage it and interoperate much better.
Now, so the framework then is binary code, like maybe a DLL or something like that's going to be running the system. That means that it's got to be written for Windows NT, Windows 2000, Windows 98, Windows 95. Which versions of Windows is going to be supported on? Are we going to run into an issue?
The framework will support all of those. Currently, the current alpha release that we have out right now only allows you to develop on Windows 2000, simply because we're just trying to reduce the bug reporting matrix. The final product will support Windows 95, 98, NT4, and Windows 2000. All of our, and indeed, the compact framework will target Windows CE. So we will have broad support in the .NET framework for all of the versions of Windows that we have out there.
Now, and then I'm assuming that the framework then is going to be an important component of Windows operating system development moving forward, and integrating it deeper and deeper so that the Windows and the applications that come with Windows are automatically just be .NET applications as well.
Right. Well, I mean, eventually the .NET framework will simply be a part of Windows. Just like kernel32.dll is part of it, well, so will these DLLs be part of it, and it will be ephemeral,
Then, with the internet being a set of systems that allow different computers to talk to each other pretty well, and I'm on a Windows system and I'm calling a .NET framework API sort of thing, and I'm calling across the net to some other system like a Macintosh or a Linux machine or something like that. Am I going to have a breakdown there if I'm not running .NET on those other systems?
No, you're not, and this goes back to what I was talking about earlier. That for any kind of distributed system, we are actually not requiring .NET be present. As I said, we use HTTP as a carrying layer, use XML SOAP for the packaging protocol. And indeed, when you develop web services with the .NET framework, we give you all the infrastructure that's required, not just to actually implement the service, but also to describe using XML the schema of your web service, if you will. What are the methods that are available in my web service? What arguments do they take? What are the function results? Those things go into SCL files, which is, a particular kind of XML.
Yeah, we talked about this a bit in the last episode.
Right. And the data types are described by XSD, which is, the W3C standard for describing data types, if you will. All of that infrastructure we give you in the .NET framework. In fact, if you think about, when I describe this to programmers, I try to sort of relate it to what a programmer knows in terms of concepts. And programmers kind of know things like, they know objects, they know classes, they know methods, they know about making calls to methods. And for all of those things, there are actually standards, either existing standards or emerging standards on the web. For objects or for data, well, there's a standard called XML that allows you to describe any piece of data, and transport it. And we provide you a bidirectional mapping between objects and XML, or XML and objects, in the .NET framework completely transparently.
So that means that the object is being re-emitted as an XML stream?
It can be serialized as XML, transported over a distributed system, or just stored for future retrieval. And then you can retrieve it and reconstitute the object from that XML.
So it'd be similar like current applications if they want to take and save their current memory state, for instance. I just kind of, point to the head pointer and say, this and the next 300 bytes are all part of my state.
Yes.
Save that to disk and read it back
Yeah,
again?
you don't actually say the next 300 bytes, but yes, precisely that actually is in the framework, and it's called serialization. And we support pluggable formatters, one being a binary formatter, which is useful if you're just, marshalling objects between two processes or two threads. You really don't care about turning it into XML and then immediately turn it back into objects. You just want to get it over the wire as fast as possible, and so you would use a binary formatter. But we also have an XML formatter that allows you, to turn it into XML, and indeed even adhere to a particular XML schema, because
like a BizTalk schema.
Exactly. Yes.
Now, okay, so let's say we've got the notion of I've got my .NET runtime-based application running on Windows, and I'm talking to some other server, Linux or whatever. Now let's say I'm a programmer and I'm working in a multi-platform environment, and I want to take advantage of some of these .NET capabilities. Does .NET itself run on Linux, run on the Macintosh and stuff like that?
It does not currently. It is designed to be technically possible to run it under Linux, but we're not making any commitments one way or the other at this point in time. What we are doing, though, is we are submitting the .NET framework, or rather what we call the Common Language Infrastructure, to ECMA for standardization. And that basically is a subset of the .NET framework that we expect to be standardized with working partners. We're also submitting C#, the programming language, to the same standardization committee, and we're hoping to kick this effort off, in fact, this month. And of course, that will inevitably, down the line, lead to implementations on different operating systems, such as the Mac OS, and certainly such as Unix and such as Linux.
But the difference there would be that, let's say Apple decided that, gee, this .NET thing really works very well. Apple could take and develop the .NET framework for the Macintosh, because
well, they probably wouldn't call it the .NET framework, but there would be a standard for a .NET-like runtime called, the Common Language Infrastructure. ECMA would have to name it. We would adhere to that standard. Apple's implementation would adhere to that standard. A Linux implementation would adhere to that standard.
And the sort of things that a programmer working with that would expect is the garbage collection models and the ability to call between
Precisely, and a certain set of base classes that you can expect to find present on each platform. Now, of course, as you go down to smaller devices, this will have to be a layered cake, right? On a small device, you're not going to want to carry around, say, interfaces to a database, because there may not be one, on this small device. But we will layer this, or work with ECMA and our partners to layer this such that, you can sort of cut it off at an appropriate level.
So then, if the .NET framework is designed with this concept of being available on different platforms, perhaps if someone else wanted to port it across, does that also mean it was designed for like a lowest common denominator approach, so you don't really have full access to the hardware you're currently running on?
No, not at all. I mean, the implementations of the .NET framework will take advantage of whatever is available on the platform that they are implemented on. Of course, if you're implemented on a small device, there's limited stuff to take advantage of.
On a coffee cup, for instance.
Or yes, precisely, on your refrigerator, However, if you're on, say, a multi-processor machine, a heavy, high-end box, we in fact have different implementations of the garbage collector, one for single processor machines, one for MP machines. And on a multiprocessor machine, we will actually tune for that environment. The garbage collector will actually divvy memory up to 4 different arenas that each processor, each thread on each processor will allocate memory from a different arena, yet the garbage collector will sort of orchestrate and collect across all 4 processors. But, that sort of an implementation reduces contention, gives you much higher throughput, and we see that in our scaling benchmarks too, that we really, really scale well, on MP boxes.
And I guess the issue there is that, like, as a programmer writing an application, accessing the .NET framework, I'm not specifically using the .NET framework to get to a feature of the current hardware I'm running on. The .NET framework is providing me services, and I'm just simply utilizing
precisely,
that
and that's that is precisely why it's important to have a set of base class libraries that, in a sense, abstract underlying services from the operating system, such as I/O.
Mm-hmm. Now, to probably try to draw everything together here, we've talked about a lot of different topics in talking about this .NET framework, which is a fairly identifiable component of the whole .NET architecture. What exactly do you think are the key aspects of the .NET framework that our audience needs to understand?
Okay, well, I think first of all it is the fact that it dramatically simplifies your application development. As I talked about before, all of this housekeeping that you traditionally have to deal with when you're writing COM applications, it's just gone. A whole class of bugs have been eliminated by the introduction of the garbage collector. Error handling is going to be way more robust because we use exceptions instead of H results. Your code is going to be type safe, at least if you're writing in VB or C#, in the sense that you will not have any uninitialized variables. It's impossible to have them. It is impossible to make an unsafe typecast.
Now, is that coming from the .NET framework, or is that coming from like C#? I thought that was a
it's
C#
actually
thing.
coming. It's in a sense coming from both. The .NET framework provides a definition of an instruction language that we call MSIL for Microsoft Intermediate Language. Our compilers target that intermediate language. So when you compile source code in, say, C#, we're actually not producing x86 object code. Rather, we're producing MSIL, which then gets compiled at runtime by a JIT compiler or at install time by the install time JIT into native code on whatever CPU you are using. So
there's that intermediate code model that is supporting the initialized variables and the type safe things.
Well, the IL in a sense gives you a base level then upon which you can build features such as code verification that verifies that your code adheres to certain rules and therefore is type safe. That's very hard to do with x86 code. You look at some x86 code and you really have no idea what it's going to do and whether it's going to be safe, whether it is never going to use a pointer that is no longer allocated, whether it's going to overrun the end of an array, whether it's going to access an uninitialized variable. It's literally impossible to see that from x86 code. But it is possible to verify that, to verify the IL. Indeed, there is a verifiable subset of the IL that the runtime will permit to run in a less trusted environment than, for example, code that you have permanently and physically installed on your machine. Will have a high degree of trust, but code that you download over the internet will have a low degree of trust and will be subject to verification. And so there's all this infrastructure in place that actually allows you to write robust code, that can be transported over the net.
And it's separate from the compiler itself.
It's separate. It's shared by all of the compilers, if you will.
So,
now, in the compiler, though, just to sort of round that out on the C# side at least, there's a core part of the C# language that's type safe. But we also support a feature called unsafe code in C# that allows you to say, hey, I need you to turn off this verification thing here. Now, I am willing to accept the fact that this code cannot be downloaded over the internet, or at least not without the user granting it more trust than it would get by default. However, having accepted that, I am now permitted to operate on pointers and do things that in the end are not type safe, because ultimately, the rubber has to meet the road, and when you're interoperating with existing APIs that are not type safe,
right.
You have to have that bridging layer. Now,
but that also then brings in the notion of these DLLs with these that aren't type safe causing them problems. And so forth. You're probably better off if you can stay within fully type safe.
Absolutely. And indeed, like I said, code that gets downloaded, you have to stay within that subset. Right. Yes.
So then it sounds to me that one of the important aspects of the framework is this whole IL model that is enforcing this type safety, which will greatly reduce some of the problems people experience today with their applications.
Well, the IL thing does many things. First of all, of course, it frees you from a particular CPU architecture, because, if you have a just-in-time compiler, well, it'll compile it to, the right CPU architecture, whatever you're running on. But as I said, the other important aspect of IL is the notion that you can actually implement a security system. You can't really implement a security system on top of just raw x86 code.
Because you don't know what the structure is at all.
Exactly, yeah.
Right. So what other aspects of the framework do you think are important that people need to understand to really understand how to incorporate their applications in this whole .NET environment?
Well, I think that, as I talked about before, first of all, it's the notion that we now all share a common set of base classes across the different languages, across the different programming models. Whether you're writing a client application, that's just going to bring up traditional client windows, or whether you're writing ASP code that goes, on the back end of your web server, the same APIs are available. The way you would do file I/O, it's precisely the same, and it doesn't matter what language you're in and what kind of application you're writing. That is very important. I think also the whole framework has been designed from the ground up to be object-oriented, if you will. So there, now we are broadly making available the notion of polymorphism, inheritance, and that way of in a sense deriving from a starting point instead of implementing from scratch. That of course has been available in some of our frameworks so far, like MFC and ATL, but it has, for example, not really been available in VB, and certainly not in when you're writing a web page.
Well, thank you. I mean, I hope that we've answered some of our audience's questions that they might have on the framework. I know that it seems like a really big topic to cover. The overview we covered in last episode just glossed over an awful lot of stuff and give a good overview. Here we've tried to dive into what one aspect is, the framework. Now I'm hoping that you'll be available for the next episode, which I'm planning on covering with C#, and I understand you've got a pretty deep understanding of the C# issues.
Yes, that was part of designing it, so definitely. And I would certainly also urge people to grab the framework, download it, play with it, and actually feel for yourself what I'm talking about.
Now on actually playing with it, then that brings up one final question: is what's the availability expected to be of this in the real world?
Well, currently an alpha version of the framework is available for broadly for download. No restrictions.
And I included information in the last episode on how to get that. And
okay.
At the bottom of the transcript, I'll put another link to how to get hold of that stuff.
Okay, great. We are currently working on Beta 1, which is slated to come out fairly soon. There will then be a Beta 2, and then finally RTM sometime next year as part of VisualStudio.net.
So then, as early as a year from now, people will actually be able to sell applications that are using the .NET framework and the .NET architecture.
But surprisingly, or wonderfully, I should say, we are actually seeing people deploy websites already built using ASP+, C#, VB on the net, real world websites.
On a pre-alpha release.
Yes.
That's pretty exciting.
Yeah, we're pretty excited about it.
Well, thanks, Anders. Well, thanks for joining us for this architecture section talking about the .NET framework. After this brief break, we'll come back and talk about the programming issues that programmers need to understand to program for the .NET framework. So join us for that. Welcome back. Now, as I mentioned earlier, today we're talking about a .NET framework. Now, Anders took and talked a lot about some of the high-level issues with the architecture and what that means to the different programming models and the different languages you might use. But actually programming to the .NET framework and understanding what that means from a structure standpoint of the code you add to your applications and how you can take existing applications and move those forward is extremely important for all of you, I'm sure. So to understand that better, I have with me Brian Harries. Brian Harries is a product unit manager for the Common Language Runtime.
That's correct.
And you've got some input and ideas on exactly what it means to use the .NET framework and applications and such.
Absolutely.
So now at the PDC, we took and first showed people what the .NET framework was. And I guess a lot of those people have actually been having a lot of fun doing some coding with the bits we handed them. Plus there's that big download you can download from our website to download some of the class libraries and .NET functionality. What exactly are people touching then in code when they're actually writing applications? What does it mean to use the .NET framework? What do they see?
Okay. Well, the .NET framework is a very broad set of things. It includes a runtime environment, the Common Language Runtime, and it includes a set of class libraries that you can use. Within those class libraries, there are a set of application models. There's the WinForms application model, which is for building sort of the traditional Windows GUI apps that people are used to with forms and buttons and things like that. There's the web forms programming model, which provides a framework or class libraries for building web applications that includes basic ability to render HTML. There's a data access ability for doing SQL queries and for taking the data returned from SQL and very quickly and easily turning it into XML or turning it into HTML that can be projected to the client to create a UI.
To probably oversimplify that a bit, and I'm probably going to be stepping on toes here, but the WinForms is kind of like Visual Basic and the Web Forms is kind of like front page?
I wouldn't quite say that. Our goal has been to take the Visual Basic ease of use and very simple RAD application development and continue to provide that for rich client apps, which we've had for a long time, and to take that same basic experience and provide it for web applications. So when you're designing a web page, it's very, very much like designing an existing form in Windows. I have a canvas that I work on, which is the web page, and using Visual Studio I can drag and drop controls, and when I've got the controls I want, I can very simply double click on the control and go into the event that I want to edit to put some code behind that form. So that's really the kind of design environment we're going for the web as well.
So not two different environments, but one environment that can either go one way or the other.
That's correct. I would say a very similar developer experience for both or application models. Now, of course, there are differences in the application models. The web application model is a loosely coupled, disconnected, generally low trust between client and server application model, and you have to worry about authentication and a bunch of those problems. And usually you're projecting HTML. And the Windows application model, of course, is a tightly coupled. Somewhere underneath is a Windows message pumping messages. So at a plumbing level, they're very different. But we're trying to make it so that from a developer experience, you're ultimately doing a lot of the similar things. You're interacting with the user, you're presenting some UI, the user's entering data, he's pushing buttons, and we want to make a lot of that sort of very similar, very familiar to developers.
Now that sounds kind of like some of the original intents behind Visual Basic, was they can create, forget about the message loop, forget about create window, forget about some of the other let's just draw things on the screen and make them work properly.
That's correct.
I know that from my own experience in using VB, there were times where I'd kind of run into this wall that, okay, I can't go any further. I'm needing access to this thing that I know about in this other API set, but I can't access it. How rich is the class library for the .NET framework?
Well, the class library for the .NET framework is very rich. It's very large. There are a lot of classes in it. Further, there's another very important design principle of the .NET framework, which is we're very familiar with sort of the VB experience of what we sort of think of as falling off the cliff. Of if I want to do what it does for me, then everything's great. But if I want to sort of do it slightly differently, I want to tweak the behavior a little bit, it becomes pretty hard, and very frequently I just sort of have to go back to the Win32 API and roll it on my own. One of the key design principles of the .NET framework is it's an object-oriented, inheritance-based system. So part of what we had to do is we added inheritance to VB in order to do this. Of course, C++ already has inheritance, and C# being a C++-like language also has inheritance. And we make use of that very heavily in our framework, where we sort of go from a very simple abstraction to increasingly richer abstractions through multiple levels. And I'm able to tie in and override behavior and call functions at each level of that hierarchy. So I can use sort of the most derived level, and it's sort of generally the easiest and the simplest and gives me the 80% case of what people want. But then if I want to do something slightly differently, I can just go up one level of abstraction in the hierarchy and work there without having to sort of start from scratch and build from the beginning.
So the class libraries are trying to encompass everything an application might need access to.
Certainly that's our eventual goal. I'm not going to say that in V1 we're doing everything that an application would ever want to do. But eventually the goal is to provide a comprehensive, very easy to use class library to solve the problems that programmers need solved. Another goal that I wanted to bring out is that we have worked very hard to make this framework very tool friendly, so that we make sort of that VB rad design time behavior easy for a tool to implement, and our Visual Studio tool has done a fabulous job building on top of that, and has done a great tool.
So that making it more tool friendly, is that part of both the framework and this minimum language support model you were talking about?
The common language runtime.
The common language runtime. So those two things work together in the C# plane of that too, or is that just the language?
Absolutely. Really, the tool friendliness has to be baked in from the bottom up into every component. There's fundamental support within the common language runtime, like the notion of attributes. There's support within the languages for letting the user expose attributes, for parsing code for the designers for parsing and formatting code. And then there's the Visual Studio aspect of the actual designer support that allows me to drag and drop things and view the properties, etc.
So if I was a compiler writer and I was currently working on a Modula 2 or a Fortran compiler or something like that, and I was following all the guidelines for integrating well with the .NET framework, it should be fairly easy then for me to add some sort of tool-like model like that to it?
Yes, absolutely. We've set out a bunch of conventions that people can use in order to get that kind of behavior.
Now, I guess also if I was a compiler vendor, I might want to take and add just my language to the Visual Studio product. Is that something that's being supported as well, or is that just for later rev?
We have the Visual Studio Integrators program that we are encouraging third parties to join, and this allows them to tie into the Visual Studio environment. So absolutely.
Okay. What sort of functions and stuff actually does the class library contain? I mean, how deep does it go?
Well, let me show you. We've got this internal tool we have here called Meteor, which basically takes all of our class libraries and processes them just to produce HTML pages off of it. And one of the things, as I show you this, you need to understand is our class libraries are broken down into a set of namespaces, like C++ namespaces, that sort of encapsulate functionality. So we've got a set of namespaces for the rich Windows application. We've got a set of namespaces for the web application model. We've got a set of namespaces for data access. We've got some things that we call the base class library, which is sort of the lowest level of functionality. So what you can see here is a pretty long list of namespaces. These are top-level namespaces within the product. Let's just drill down into one just to see how much stuff is in these namespaces. Let's look, for example, at WinForms, which is the namespace for creating rich Windows client applications. Within a namespace is a bunch of classes, and I'll just page through them so you can kind of get an idea of how much there is.
Now, I assume this list is actually being generated dynamically by enumerating through the class library?
That's correct. We've got a tool that processes through the actual DLLs that we ship and produces this stuff. One of the important things to understand about the .NET framework is all the components are self-describing. This is an incredibly important feature that we use to give sort of very rich development experience and also to give some very good deployment capabilities to simplify a bunch of the deployment problems that people face today. For example, every component describes both what is in it, what classes are in it, and what it depends on. So if you've got problems loading an application, you can go find out what it depends on, say, oh, I'm missing that DLL, and makes it a lot easier to manage our applications. And I just keep going. This is just the rich Windows, and as you can see, it's hundreds and hundreds of classes in the rich Windows model. So let's pick one of these just to drill down into, and I'll give you an idea of how much stuff you can find on in a class. Let's take the file dialog class, which is sort of a wrapper for the standard Windows Common Control file dialog, and it'll have a set of methods, things like onFileOK, which is an event that's fired when the user hits the OK button on the file dialog, and a set of properties for setting whether the dialog is going to check if the file exists, if the path exists, etc.
And so you set those just like you set properties in script code or something like that?
Absolutely. Many of them can be set in the design time environment. In Visual Studio, there's a little properties dialog, which I'll show you in a bit, where you can just click the values of the properties, or they can be set in code for what you'd like to do. Let's pick, let me shut down the WinForms one here, and I'll go for a minute into something else, just to go into a completely different area of the framework, give you an idea of how broad it is. Let's look, for example, at system.io. Everybody needs to do file I/O and network I/O, etc. System.io has a set of the base primitives for I/O. It's got definitions of stream classes. It's got a definition of a file and directory classes. So, for example, the file class has all you would need to copy files, to create files, delete them.
Now, one thing I'm noticing here is like this delete function. It says it takes a string parameter into it, and it even tells me that string parameter is the path.
That's correct.
So it's documenting to me what type of information it's expecting there, and so that's all part of when you wrote the delete function, the way you described it in code, self-document it clear at
That's
this level.
exactly correct. So that sort of feeds back into what I was saying a minute ago about one of the key aspects is that the .NET framework supports self-describing components. In fact, requires self-describing components. So not only does it tell you what's in there and what it depends on, but it also tells you how to use what's in there. It tells you all the parameters and their types. And I'll show you some very cool features in Visual Studio of how it uses that information to make the developer experience absolutely wonderful.
I remember in the early days of the releases of many other operating systems and things, one of the problems developers would have in the alpha and beta stages is when the function built into the operating system didn't match the documentation, because things had changed between writing the documentation and actually implementing the function. And so this makes that impossible to happen there.
Yeah, it does. It makes you go back. It makes it a lot less frequent that you have to go back to help. Because the information, as I said, I'll show you in Visual Studio, the information is just there as you type. Visual Studio is reading that metadata that describes describes the functions, and is prompting you with telling you what the parameters are and what their types are.
Now, since this is part of the way C# and the .NET framework and the other languages that participate in this works, this means if I was an application developer at Boeing or something like that, and I was writing my applications, my components, and so forth, this would also be documenting what I was writing too?
That's correct.
And so my components could now be exposed to the other users in my group that might be using it in the same fashion.
That's correct.
Well, that's exciting.
So let me just sort of hit a couple other areas in the framework again, just to give you a flavor of what all is in here. There's the system.data and system.data.ado, which is all of our data access. It supports both connected and disconnected data access model. Again, I'll just click on this briefly and show you again. Lots of classes that provide all the different functionality of databases. Another point that I'd like to make is that our data access is very integrated with our XML. We view this as a huge advantage of the .NET framework, of allowing you to view the same data either as an XML tree or as relational data, and to be able to transform that data back and forth as necessary. We think this is a very valuable feature, especially in web-based programming, where what you're generally exchanging over the wire is XML, and then you want to manipulate it with relational tools, both on the server and on the client. A couple other things I just want to point out. For example, we've got system.com services is in here, which is our wrapper for the, Microsoft.com services, which is our wrapper for the existing Win32 Com Plus functionality, which gives you automatic transactions and object pooling and queuing and features like that. We've got a bunch of compiler support classes like system.codedom, which it's just an interface for parsing code for designers.
I'm noticing these Microsoft dot classes.
Yes.
I'm assuming that means these are specific technologies that are Microsoft technology putting in there. Does this also then mean that other companies that have technologies they want to add to the system, they would have their company name in front of it?
That's correct. So the way the naming is, the naming convention is, quite honestly, it's not particularly enforced, is that the system namespace is sort of for generic system functionality.
Like file I/O.
Like file I/O, like database access, like GUI, like some basic web APIs. And then for Microsoft-specific functionality or company-specific functionality, that's designed to go in a namespace that starts with the company name. So we have a bunch of Microsoft namespace things, and then most of the stuff that we've done to date has been in sort of the category of basic system services.
So if I installed, let's say, AppleTalk drivers to my system that were written in that framework, it would say apple.network.appletalk or something like that.
Yes. Yes. So I think that probably covers most of it. We could spend hours just going through all the different support here. There's a broad set of web namespaces that handle security, that handle the UI, that handle support for what we call web services. There's been a lot of talk about web services lately. The basic notion is this notion of cooperating components across the web, where I can make a function call, have that turn into an XML message, deliver that to a server across the internet, have it process that XML message, and return a value, and have that turned back into XML and return back to me.
Or your application didn't even realize you're doing XML on the stream.
That's correct. And we abstract that away from the user having to deal with a lot of flexibility for creating creating the schema that you want out of your parameters, because ultimately the schema is what matters on the wire. A very powerful programming model for really taking the web to the next generation. The web has been sort of so much about a server projecting HTML, and web service is about a collaborative web environment where servers are working together and clients are working together independent of presentation, but instead exchanging data that can be processed independently to create rich local interfaces, to aggregate services across web servers, etc.
So from a programmer standpoint, actually using some of this great class library functionality like this, what is their experience like, and how can they actually make use of these things?
Okay, well, let me do a little demo for you in Visual Studio. And I've chosen to do a WinForms demo. I could have just as easily have done a web forms demo or some data access.
So it's essentially you're going to be writing a traditional Windows application.
That's right. So this is Visual Studio 7 or VS.NET. If you went to the PDC, then you have a version of this.
But this is not, well, this was at the PDC.
That's
this
correct.
Is not part of the download.
That's correct.
That you get off the website.
Visual Studio is not part of the download. It was handed out at the PDC. It will be available again when we do a beta later this year. Most everything I'm going to show you, in fact, I'd say everything I'm going to show you, you can do purely with the SDK. You just don't get the really rich and nice design environment that we have here in Visual Studio.
So that's just another reason to go to the PDC.
So I've just created a new WinForms project. And that's going to come up. Comes up in a default view with a form, an empty form, very much like VB would do, for me to now work on. So let's just create a very simple form as to illustrate some of the basic principles. You'll notice I can, very VB-like, just I have this toolbox over here that I can drag and drop controls, and I can resize them as necessary. Just keep dragging them on here. Let's throw in a couple of buttons and another button. Make it look a little bit pretty for you. And then we'll add a list box. And I'm not going to make it look perfect, but there you go. And I mentioned earlier about how a lot of the properties can be set inside Visual Studio, and you don't have to, you can set them in code or in Visual Studio. So let's take, for example, the button, and I want to change the text of this button to add. So I can click over here on this property grid, which is context dependent. Depending on what control I click on, different properties show up. So I will change the text of that button to add.
So just to clarify, in the earlier demo, we're looking at the Meteor demo, we saw system.winforms.blah-blah-blah.
That's correct.
What you just clicked on there was systems.winforms.button.
That's correct.
And in the same way that in your window view, you were seeing all the properties, methods, and events exposed by button, this is just showing you down here in the properties dialog those properties.
That's correct. This is showing you the properties. There's another tab here that will let you see the events. The methods don't show up here because there's no design support for the methods. That's for you to code to. So I'll change the name of this one to delete. And last thing I'll do, just for the heck of it, is remove the text out of this text box. So here we have a button, or a dialog with text and a button and some buttons on it. And what I'm going to do is now write some code behind this form. So what I'd like to do is whenever I type in this text box, I'd like to change the enabled or disabled state of the add button. And ultimately what I'm imagining I do with this is write something that I would type and add what I type to the list box. So all I have to do is double click on it, and that's going to take me out of the designer into the code. So before we actually go and write the code for this, let me just show you a little bit around this source file. So everything I just did is represented in this source file. The designer, what it actually does, it doesn't create sort of the Win32 resources that we're used to, which is a declarative view of your form. Instead, it generates code. So what that means is all of that code is available for you to modify and tweak any way you want. It also means you don't have to have the designer to do anything. It's all there in code. So one of the key aspects is, for WinForms is this this function called initialize component. Initialize component is where most of what I did in that designer actually shows up. It has generated all the code to create each of the controls. So you'll see a new of system.winforms.textbox and button and label and listbox and another button. And then you'll see all the property setting. Now a bunch of these were set by default. Only a few of them did I actually tweak.
So here's like that button.text equals add.
That's
and
correct.
So that's where you click in that box and you said add, and that changed the value.
That's exactly right. And button.text equals delete, and it's automatically put in all of the properties for the location and the size and the tab index and all of that. Now, this can actually, for a fairly complicated form, this can get pretty complicated. It can get to be a pretty long function. And you don't always want to be paging up and down over that. So I want to show you a neat feature of Visual Studio is they've added an outlining mode where I can just collapse that whole function, and that turns into a plus, and it's got this little ... out here to let you know that there's some more code behind there. And now I don't have to see that code generated by the designer. But I always can go and modify it if I want. And in fact, I believe that in the Visual Basic projects, that will be the default. You will not see the code that the designer has generated.
Well, because they're not used to seeing the code, because that's always usually kept in a separate form file.
That's correct. They've never seen it before, and we don't want to change that experience for the VB developer. So let's write a little code, and let's say that, again, what I said I wanted to do is make it so that the enabled state of the add button changes based on whether I have typed any text or not. So let's start by, since when I pull up the form, I haven't typed any text, let's start by setting that to disabled. So we'll just simply type button 1 dot, and you'll notice this pop-up just came up as I was typing, and essentially it happens as soon as I hit dot, it says, he's going to type another member here. It knows that I've just typed button 1, and it knows what button 1 is. It knows it's a button. So it goes into that DLL, that the WinForms DLL, and says, okay, show me the methods and properties of buttons so that I can present them to the user. And you'll notice also as I type, it sort of incrementally goes to where I want. And when I hit space, it's done. And I can here say false. So we've disabled the button by default. And then let's go down to the changed field.
And actually, what you could have done there instead in the design mode, you could have scrolled down the property box and set that value to false. It would do the exact same thing.
Would have done exactly the same thing. So here's my event function that the designer inserted for me when I double-clicked on the edit control. So now I need to make it so that as I type, it changes the state of the button. So we'll just very simply say button 1 dot enabled equals. Now I want to look at the text box. So it's text box 1 dot. And now again, I get this, and this time I want to look at the text property, which is the property that always contains the contents of whatever's currently in the text box, not equal to empty string. So basically that says, if it's not empty to empty string, if it's not equal to empty string, then I want the button enabled. If it is equal to empty string, then I don't want the button enabled. So let's just take that and build it and run it. And you'll see the add button has initially come up disabled, and as I type, it re-enables, and if I delete all the text, it re-disables again. So sort of a very simple programming model, very nice integration of the designer with the source code. You can do a lot of things in either one, either using the designer to drag and drop and set properties, or just go into code view and type as you go. And you have so much help as you're going from Visual Studio, prompting you, sort of given the context that you're in, what you've typed so far, what the possibilities, the choices you have at this point. And what I showed you here, I didn't actually call any functions that took any significant number of parameters, but it can show you both the member methods and properties if I type a variable or a class name, and once I sort of hit open paren on a function for the parameter list, it will then pull up the choices of parameters. Let me just do that just so you can see it. So I'll say like this dot, oops, controls. I'll just replicate one of these lines up here. And now I hit the open parens, and it's going to tell me both the type, which is a control, it wants a system.winforms.control, and the name of the parameter, which is at this point called value. So this, just is a huge productivity advantage. Now it's not new to VB programmers. VB programmers have had this, but it is just a massive, or I should say, VB programmers have had this for some controls. VB had a documentation mechanism for doing this kind of thing.
But that was the same for that in VB. Somebody had to actually take and write some sort of separate file that maintained all this information separately, whereas you're actually walking into the structure that was written, as was written, and passing it on.
In a lot of cases, that's exactly correct.
Now, so from a program standpoint, it sounds like this would greatly increase the productivity of programmers have less chance for getting the wrong function called, getting the wrong parameters listed, not understanding how to use a particular function, getting the documentation that's one rev back and having to figure out how that relates to the current rev. Do you see that the same level of productivity is going to be equally valuable for both the web and for the Windows applications on the platforms?
Absolutely. This same tool provides exactly the same kind of features for whatever application model you're using, whether you're using the WinForms application model or the web application model. If I had been doing a web page instead of a WinForm, it would have felt very much the same. In fact, I would have a form and I could drag and drop controls out of the toolbox. I could set properties, I could double click on a control and it would add an event handler and I could go and modify that event handler. Again, since the application model is different, some of the API functions I would be calling would be different. And of course, what's happening under the covers is very different. There is, however, a large set of things that are completely common across both application models. The whole base class library, file I/O, data access, net classes, etc., are the same, and then we just have these two application models that sit on top of all of that and provide a very rich and powerful way to build applications within that application model. But you're not limited to just those two. We talk about those two a lot because they're the kinds that lots of people like to build. But you can build command line console applications, including from VB, which is something you didn't used to be able to do particularly easily. You can build NT services, including from VB. Again, something that's not particularly easy.
But now using the class libraries, that makes it really easy.
Yes, it does. So we've provided a very general system for building any kind of application you can build today, and they're available to all the languages.
So what then do you think, just as a closing remarks here, that you think are the most important things for application developers to understand about what the .NET framework provides them and why it's important to their development moving forward?
Okay. The .NET framework is a multi-language environment that provides you a choice of what language you want to use. It provides, its primary goal is about making development easier, faster, more productive, to create the rich applications that you know today, and to do new kinds of applications like web services that either can't be done today or are at least very hard to do today. A lot of plumbing has to be written in order to make it possible. Also, to enable safe and secure deployment, we have a bunch of features that eliminate a bunch of the problems we have today with COM components around system instability by when I update software packages, and we have globally shared components. In addition, we have a security model that enables mobile code to be downloaded over the internet and used without sort of a lot of the virus problems that we have today. So those are probably the key things I'd like people to come away with.
Well, thanks, Brian. Now, I suppose there's probably some users out there who are watching using Visual Studio and they weren't at the PDC and they would love to get their hands on something like that. What are their options?
Well, today the best thing to do is to download the .NET Framework SDK from msdn.microsoft.com/net, and it has in it everything you need to do everything you saw me do today, except for the design experience part. And we even have a fairly simple designer to enable you to do a lot of that. It's called Windes. But it includes the VB compiler, the C# compiler, and the managed C++ compiler. It also includes all the libraries that you saw there described in Meteor, and basically everything you need for building ASP+ applications, for building WinForms applications, for building command line, etc. As far as Visual Studio goes, if you were at the PDC, you got that on the CD. If you weren't at the PDC, we've not been distributing that in any other forum. It's going to beta later this fall, and you can sign up for the beta also, I believe, on msdn.microsoft.com.
Okay, and I'll include a link to that in the bottom of the transcript window that shows people how they can connect up to that. Okay, well, thanks a lot, Brian. I appreciate the information you shared with us, and I'm sure our audience out there figured out why .NET's important to them.
Great.
So thanks for joining us with this episode about the .NET framework. Hopefully you saw some aspects of why the class libraries and some of the tools coming out really can help you an awful lot in developing your applications. Now, in the next episode that'll come back in about a month from now, we'll be talking about C# specifically, and so that'll greatly tie into some of the things we talked about today. So thanks for joining us, and stay tuned for the rest of the show.
With over 8,000 managers, Microsoft places high value on strong leadership. With me today is Sabina Nawaz. She is Director of Leadership Development at Microsoft. Sabina, welcome. Thanks for joining me today to talk.
Thank you, Erica.
So tell me a little bit about what it means to be Director of Leadership Development, what that entails.
Well, we try to focus on our leaders in the company and see what we can do to help them better impact their business results and improve their organizational, their team, and their own leadership performance, so that we can create great leaders in the company and also build a bench of leaders that form a row, that form a succession of leadership through the organization.
And what are some of the biggest challenges that entails?
Some of the challenges are keeping up with the pace of the company. There are so many changes going on, both on the technical side as well as organizationally. And so what our team does, works really hard to do, is make sure that we're in touch with what's going on in the business and then figuring out what our leaders need based on our business initiatives. An example of that is the current .NET strategy. That involves a lot of changes in how we do things in the service business. And so our challenge currently is to figure out what do we need to do to help prepare our leaders to face that challenge. And there are really two major areas that we look at there. One is around leading change. As a leader, not only do you need to understand and embody the principles of .NET, but then you also need to lead the company into changing and building that around that initiative. The second piece is around building great partnerships, both internally across a variety of different groups who need to work very closely together in order to create a seamless experience for the customer, as well as across our partners in the industry and beyond, so that we can create a fully integrated set of applications and platform for the user. So from a leadership perspective, we are working on offerings and material that leaders can embody around both leading change as well as cross-group cooperation.
It's quite a handful, very challenging. So besides .NET, are there other types of things you're focusing on with leadership development?
Yes, so in addition to .NET, we're also looking at, in general, what are some key leadership criteria, and how can leaders succeed in those criteria in the high-tech, rapidly changing environment and in a place like Microsoft. So in general, the change initiatives as well as partnering are important, regardless of whether you're working on .NET or whatever product. In addition to that, we also have leaders take a real hard look at themselves. What are they about? What are their fundamental values from which they lead? And do their values then show up in the behaviors that they exhibit in the workplace? So how can we help leaders become more self-aware of their values? What do they feel strongly about? What are they passionate about? What are they willing to put their names on the line for? And then how can we get them to then be effective communicators, set clear goals and objectives around those values?
So are you mainly working with current leaders and managers at Microsoft, or does your job focus on recruiting people that would make potential great leaders at Microsoft?
We mainly work with the current leaders at Microsoft. However, given that there's a range of leaders, over 8,000, that does involve building a bench of potential leaders. So it all depends on which level of leadership you're looking at. So we have brand new managers who come in, and that's a sister organization to mine, and they have a very solid curriculum for very new people who have not managed people before. Well, you could say that we're building them to be leaders for more seasoned managers when they then manage managers underneath them. And so on and so forth. So we built that bench and progression throughout. In addition to that, the Management Development Group, which is the sister organization, also has opportunities for people who are identified as future managers or leads, and provide them with training and other sorts of resources.
That's great. So how long have you been at Microsoft?
I've been at Microsoft about 10 years.
10 years, wow. So how did you get to the point you are now? What were some of your first jobs at Microsoft?
Well, my first job at Microsoft had nothing to do with this group. I studied computer science and computer systems engineering in college, and then I applied for about 260 jobs. Microsoft was the first one to call me and offer me a job. So I moved to the West Coast and started as a developer in the hardware division of Microsoft, working on the Windows sound system. I was the first person hired to work on that product. And so I've essentially been in product development for 9 years, working through development. I was a test manager, worked on products like Windows 95 and Internet Explorer, and then moved into what we call program management. And I was the group program manager for MSN.com before I decided to completely switch careers and take on the challenge around our leadership and management development.
Yeah, it's quite a jump.
Yes, it's a very different job. However, there are a lot of elements that are really similar. I still manage people, I still deal with managers, and I still deal with Microsoft and Microsoft people and products.
Sure. So tell me a little bit about what you do for fun, what you do outside of work.
One of my biggest passions outside of work is acting. And about 3.5 years ago, I attended a beginner acting class at Bellevue Community College. And I was so inspired at the end of the class that I decided I was going to start my own theater company. So I recruited everybody from the class to join me. And if I'd known what was involved in starting the theater company, I would never have taken it on. So I guess I'm glad I didn't know. And we've been in existence for about 3 years now. We put on about 2 shows a year, and it's just a blast. However, it's also a lot of time. We have rehearsals. When we are in rehearsal, it's 4 days a week.
Oh, wow.
So that keeps me busy.
I bet. What type of productions have you done so far?
We've done a wide range of productions, and the productions change based on our skill levels as we progress through this and learn more and more about theater and stagecraft. So we've done things ranging from a short farce to Neil Simon to Shakespeare. And our current production, which we're in rehearsal for, is called Wall of Water, which is a farce.
It's a farce?
Yes.
Can you tell us a little bit about that?
It's this really crazy comedy. There's 4 women living in an apartment, one of whom is insane. And one of the other roommates hasn't been told about the fact that this roommate is actually insane. And she has these episodes. And when she has these episodes, everything goes into chaos. And in the second act, there are 4 men who enter the apartment in various relationships with the women, and it's a whole farce about mistaken identities and mistaken intentions.
Do you tend to draw from your day job into the type of productions you do with your theater group?
I don't know that I draw from the day job on the types of productions I do, but I think that a lot of what shows up in stage is definitely influenced by my day job.
Sure.
One of the examples is improvisation. At Microsoft, because things change so much and so much is happening all the time, there's a lot of times I feel like I'm improvising my way through something. And it's a real blast, and that's something that I carry into the acting area and do as well.
That's excellent. Now, you said if you had known what it would take to start your theater group that you might have thought twice. What does that mean? What was challenging about that?
It's just a lot of work to start your own theater group. We started with no real knowledge of what it involves, all the behind-the-scenes work. We didn't really have a set designer or a stage manager or a lighting person, and didn't even know all those were needed. So part of it was just the awareness that there's a lot beyond just the actor, since of course as an actor it was all about me and nothing else. So first it was getting the resources, getting to know what the resources involved were, and then finding out people who would do it, who would like to do it, want to do it for us, and above all do it for free. So we have been really lucky in actually attracting a lot of really good talent and a lot of great people who poured their heart and soul into theater. So that has been a really rewarding experience. The other part that was a lot of work was the fact of setting up an organization, going through the whole nonprofit process and building a 501c3 org, and then creating a board of directors and running that. And that's a place where definitely my day job has come into a lot of use.
Sure.
It's essentially like a program management job, and it's also a leadership job in running the organization.
So what other type of things do you do outside of work besides theater? When you have time, I can imagine.
I love to go sailing, and I love to cook. In fact, I teach cooking, and in my spare time, which is not very often.
Right.
I also am involved in the steering committee of the Seattle chapter of Women in Technology International, which is an organization that promotes women in technology. And so we hold events about once every other month, bring in speakers to talk on various topics ranging from career development to the latest technologies out there. And about 100 women in various areas of technology show up to these events.
Okay, you're encouraging women to go more into those fields. I imagine the numbers of women in technology have increased in 10, even last 5 years even.
Yes, definitely. There's been a huge increase.
Excellent. So what type of, you said you like to cook, what type of cuisines are your favorite things to cook?
Well, I'm from India, and I'm afraid my cooking experience is pretty limited to Indian cooking.
That's excellent.
I am trying to be more adventurous and venture into some of the other types of food, but it's mainly Indian cooking, and that's what I teach as well.
That's excellent.
It's really surprised
I'd
my
like to
mother.
try some sometime.
Okay.
So you've been at 10 years at Microsoft. What keeps you going?
I think there are a couple of things that keep me going. One is just getting to work with the people that I get to work. I sometimes, even after 10 years, have to pinch myself to see if this is real. The people are so smart, so motivated, so helpful. It's just a great team atmosphere. And I love the work that I get done in the hallways or on my whiteboard because somebody just stopped by to brainstorm on something. So I think the people is a very strong aspect of it. A second part of that is that I love change, and I get bored in about 2 years, whatever I'm doing. And Microsoft has allowed me to change jobs and also careers. So it hasn't been a place where you just come in and do a job. It's a place where you can build your entire career. And so I've never felt that as long as I'm in the computer industry, I ever need to go somewhere else to work because of those two things.
That's great. So what type of changes have you seen in the company in 10 years?
Well, firstly, the size of the company.
Sure.
I believe there were less than 6,000 people when I first started, and now there are, I think, 39,000 people or so in the company.
Something like that.
So just my Microsoft Manager customer base is larger than the number of people that were in the company worldwide when I started. So the size has been a huge change. However, what I've liked about the increase in size is that it has not changed appreciably the autonomy or the authority that's driven down to the lowest levels of the organization in terms of getting our job done and working in small groups. Other things that have changed along with the size of the number of buildings and the choice of cafeterias that you get to eat at. So that's been interesting. We've also certainly made a lot of strides in terms of leadership development, in terms of growing the number of leaders that we have in the company now. So we have a wide range of leaders and managers taking care of the business.
Well, that's excellent. Well, thank you so much for joining me today, taking the time to talk. It was excellent. Thank you.
Thanks.
Thanks for joining us for another episode of the MSDN Show, this time talking about the .NET framework.
The next episode of the MSDN Show will talk about C# and how it integrates in the .NET programming architecture.
Until then, we'll see you on the web.